All right, it is almost 9 o'clock, Joel. I'm going to start turning off cameras and microphones. You guys will have the ability to turn those back on once it's time for question and answers. But in the meantime, if you have questions, go ahead and put those in the chat and we will monitor those. We will ask those when Chris takes time for questions. And there will always be questions at the end, so feel free to turn your mics and cameras back on then. So with that, I think we will get rolling. Chris, you ready? You are on mute right now.
Oh, yeah, no, I know.
All right.
Yep.
Just wanted to make sure you know. So, all right. I am going to go ahead and turn off the videos and microphones for people. And thank you guys for joining us today.
All right, good morning. Welcome to all of you online with us and those who will be joining us later for this webinar today on battery storage curriculum and labs. I'm Joel Shoemaker, one of the co-principal investigators of CREATE, which is the Center for Renewable Energy Advanced Technological Education. We've been doing a number of webinars, and a minute later, we'll talk about some of the upcoming ones that we have. Today, we have Chris Miller, a distinguished professor at Heartland Community College, who's going to talk about one or more of the labs that he's created in an energy storage course that he's developed. Chris and I, our collaboration goes back more than, I think, a dozen years. We first met in Costa Rica, both taking a class on installing solar and batteries in a developing world context. We've done many things together since then, including taking students to Belize to do similar things, install small solar electric systems with batteries. And I have personally learned a lot from Chris about how batteries work and how we can use them with renewable energy systems. More recently, Chris was one of the participants on a trip that we took to Germany to learn about the latest developments there with renewable energy and energy storage in particular. Chris, teaching at Heartland Community College in Normal, Illinois, has an electric vehicle manufacturer located close by, Rivian, and inspired by them and by his college's commitment to training people for their local industry, has been working on expanding the technician training regarding battery energy storage. So Gabby, let's talk briefly about the upcoming webinars before we turn things over to Chris. We will have Jim Pytel talking about how he has flipped his classroom and used motor control trainers in an innovative way. So we'll look forward to hearing from Jim on February 24th. And then later on, or sometime in February, we'll also hear from Eric Knispel about biofuels or some of the activities that he's developed for his students regarding biofuel combustion. If you have any questions about the webinars or to get on the email list to get the invitation to them, email Gabby Temple. As you can see, the email address is there. And more broadly, any previous webinars, this one included, pretty soon will be posted at our website, createenergy.org. So without further ado, we'll turn it over to Chris. And as Gabby was mentioning earlier, if you didn't hear, you can post questions in the chat and we'll monitor that. So when Chris takes questions, we can make sure to get the questions asked. Take it away, Chris.
Well, thank you, Joel. Thank you, everybody, for your time. I'm going to set up, I've got a second screen here. So I'm going to do that. Give me just 1 second. And come on, there we go. So I don't even know where to begin with all of this. There has been a whirlwind of activity here at our college, and I wanted to develop a battery class. We were kind of forced into building a battery class for a local manufacturer, Rivian. And I've got a lot more information now, and I understand what they're doing a lot better. And I have a better idea of how to present materials for my students. So what I'd like to present on specifically is an innovative, it's not really as innovative as it might be, but a way that allows us to offer some hands-on skills for students in both the hybrid and online format, in addition to being in person. And what I've tried to do over the last couple of about a year and a half is I developed a bunch of labs and activities, and Gabby in the chat will very shortly push this Google Drive. And I am willing to share with you everything that I've developed, all of my labs. In fact, I even zipped up the Canvas shell so you can have everything from all my tests, all the answer keys, all the labs at the end of the dog and pony presentation of the PowerPoint. I'll be more than happy to kind of show you the layout. A lot of it has not been vetted by anybody but me and my students. So I need some assistance just saying, hey, you got a typo here, you got something going on with that. But I feel pretty good. The students really got a lot out of it. Rivian was very happy with the results. And a few students that had gotten COVID during the semester and had to miss a week or two found that the video activities that associated and stepped through the lab activity really helped them keep up with the class. So while they might not have been able to do one or two very specific hands-on labs during the week they missed, they at least still did the labs, completed it, submitted it, and we weren't too far behind. And that was a pretty good solution to some complex problems of students coming and going at different times. So that Google Drive should be showing up pretty quick. And like I said, it's all there for you to take a look at and just give me feedback of what you wanted. To start off this large discussion, just a little bit of a boring background. When Rivian came to town, they decided to assemble their battery packs in the facility. And the school, and talking to them, recognized the need from an energy storage standpoint and a manufacturing standpoint. And we still don't have a very specific or solidified solution to what they need. But what has been teased out from both the discussion from the energy storage side, from our renewable energy folks, both in the wind and solar, and from Rivian on the assembly and manufacturing, is we wanted to have an open course with no prerequisites and the ability to understand how to assemble a battery, understand definitions both in the energy storage and manufacturing side. And so we developed this Renewable Class 234 to kind of bridge that development. The specific activities that I did, and when you go through that Google Drive and look at all the labs, when we created the labs, what I wanted to have happen was I would cut some short videos, but as Jim Pytel, who's on the conference, can attest to, it's very difficult to keep them to a very short, sweet, under 10-minute standpoint. But the goal was to have a in-class lab that was a step-by-step guide to doing whatever particular activity was in place, and then have about a couple 10-minute videos, depending on how to navigate that specific activity, that a student could on their own, after class, before class, whenever, even during class, have the same steps and process. So that was the spirit in which I built many of the labs for the class. Now, when we get to looking at this layout of the class, what we did, I don't even know where to say, but the hands-on activities worked really well. And the second part of it was to have an open source textbook. And so this course is based on an open source free book, and it did well on battery assembly and talking about batteries, but we wanted to have kids actually build a battery pack. And so this activity is going to lay out specifically how to use some lithium iron phosphate cells, put 4 of them in series, get a 12-volt pack, and put a BMS onto that. Then we're going to take 2 of those battery packs that the students built and then attach it to a Midnight Solar do-it-yourself charger inverter combo to talk about energy storage. And we're now moving into the next iteration. Do we have a standalone class on energy storage, or do we tweak this battery class? So my specific activity here was looking at the most important aspects that Rivian and what our Renewable Energy Advisory Board was. And that was just to get a great idea of the fundamentals of energy storage and then how batteries were assembled. And when I go to the screen and off the PowerPoint, I'll show you our Rivian cells, and they're just a standard 2270 cell. So we're going to use a prismatic cell, and I'll show you pictures in a moment, but they're a little bit larger form factor, and using lithium iron phosphate, they're far safer from an in-classroom setup and storage containment. And so when we talked to our local constituents there, this was a job task analysis that we came up with. And again, I know that we're working with NABCEB to come up with the job tasks, and they are developed. So this was looking specifically at safety and battery side. And just to give you a perspective of what we're doing, what we came up with on our own with those ideas there. As our school has moved more and more onto the online format, one thing that has been pushed on us is to make sure that all of our videos and supporting documentation are handicapped and ADA compliant, handicapped accessible. And so one thing that we've done in pushing everything into Canvas, as most of you are aware of, is the fact that we could embed closed captioning within that. And I think we're now using Ouija, I'm not sure what the name of it is, but we're moving away from Canvas Studio into this other Ouija that will do automatic closed captioning. But the videos that I've done on this have the closed captioning embedded into it. And specifically, if you use the Canvas shell to extract, you will have that at your disposal. So these videos were meant to be a standalone product in conjunction with what we've got. And so I tried to build this single installation of the battery, and I've got it right behind me here, and I'll pull a picture up, but physically and show you. But it was meant to be about a 2-hour lab. Then we come back the next day or the next class period and do the next one. And there are 3 main labs to building a lithium battery pack. The first was doing a top balancing. And I'm not sure if it was good to talk about the process of building it. And I've got the lab activity, but I found that it was easier to have a lab assistant top balance all the cells prior to them building the battery pack. That was one thing that I learned. I know I'm getting a little ahead of myself, but I'm hoping to build some talking points when we get to the question and answer that you might have on that. So this was kind of my idea of a short, sweet, to the point. Prior to these students who got to this activity, they did do a multimeter lab. They did do a basic Ohm's law, so they have some of the basic electrical knowledge, but many students had never seen a multimeter when they took this class. So there was a bit of a learning curve between the installation and designing, setting up of the battery management system and talking about amp hours and kilowatt hours and actually touching something that is electrically charged. And so that was that. So the very first step of doing this is I had them go and use a multimeter and measure each individual cell. We talked about balancing of cells. We talked about the chemistry up to this point. They understand the anode and cathode of the individual cells. They have very limited, but we did do a small activity on series and parallels, but not to a great extent you would see maybe in a more technically advanced class or in an electronics-based class. After that, we then did a similar activity where the students then did series, parallel, and we did definitions. Again, I will pull up on their screen the actual lab, or if you're listening in and going to the Google Drive site, you can pull up, this will be lab number 21 of building a lithium iron phosphate battery. But we talked about these terms and conditions, and then we talked about how to series parallel and a little bit about how the battery management functions. Our objective is just enough for the students to be aware of what it is that they're seeing either out at Rivian when they're doing assembly of the cell packs, or whether they are in the EV side of repair and they have a large high voltage battery pack and the breakdown within that battery pack and how it functions and operates. So, like I said, there were 3 specific activities that were designed for building of this lithium iron phosphate lab. The first one was reading the data sheet of these prismatic 40 amp hour cells, then talking about top balancing of them, which means that all 4 of those cells in this particular case were exactly at the same state of charge, so they were all perfectly balanced, and then doing a final inspection of the cells and then making sure that the battery pack of the 4 cells are together. That would be lab number 1. This activity that I'm showing you here is step number 2, or lab 2, where after that's been done, the students will take the battery management system, attach it to the side, connect the individual cell monitoring points, do the plus and minus, and then attach it into the cabinet, marine size 21 marine cabinet that we have there, or box. And that, I'm going to air quote, is the battery itself. So the lab this go around took a lot longer because I had the students do some crimping and do some shrink tubing that I won't have to do in future labs. So I'm hoping that this becomes a much shorter lab where we just talk about the concepts, put our PPE on, assemble these items, and then move on to the energy storage side of taking them and adding them to the Midnight Solar charger inverter combo and getting into that. And so what I found was the students were extremely interested, but what was difficult doing it was as a step-by-step between the video that supports this and then the versing the in-class was the attention to detail. For example, I wanted to have the students indicate 4 tick marks or 3 tick marks on each one of these pieces of wire that went to the BMS so they could see why, if they were looking at cell number 2 or cell number 3, which connection went back to the BMS. I just need them to pay attention to reading the data sheets and reading a schematic and saying, okay, if this is the white wire that's going to wire terminal number 2, it needs to go to this cell. Because at Rivian, they're using a laser welding machine that is going to be fully automated. So from a installer standpoint, all of the battery packs, at least at Rivian and most likely Samsung, when they build the battery packs, are all fully automated. Where they're running into problems is at the individual cell pack level, the 52 volt packs that comprise 9 of them to make the high voltage battery pack that sits on the skateboard, is they will take that one battery pack out and then replace it in the manufacturing, and then they will recycle, or they're still figuring out all the details of all of that. But as far as a technician, we are not getting to any cell level repair out there. We're gonna start teaching a high voltage architecture class on cell technology, but that will be a specific to Rivian course. Our students that are in the electric vehicle program and the industrial maintenance and renewable program will only look at this at a 12 volt layer. So it's just enough of schematic reading, diagramming, and at this level right here. So one thing about lithium iron phosphate, as many of you are aware of, is that there's very low risk to fires with them, and they have a rather robust short circuit condition that if they do short circuit, the risk of a fire is very small. So from a safety standpoint, at 40 amp hours at 12 volts, there's still a significant arc, but not enough that with just proper safety glasses and leather gloves and long sleeve non-synthetic shirts, I feel pretty comfortable having my students assemble this pack. So that was nice with that. I did run the class, and I did have 2 students that could not do the final assembly, and it did not seem to impact them by watching the videos and going through the step-by-steps on their own to answering just some understanding of knowledge-based questions on the final exam. Did they certainly lose out on the hands-on and the the involved aspect of the details and orientation? Yes, I did find that, but it was nice to keep my students all on the same pace with that. So the last thing that I was going to do for lab number 3 is, after the battery pack was built, I have just a small modified sine wave inverter hooked to a kilowatt, and then we were going to hook up to a light bulb and a small fan and measure the amp hour rating, the watt hours, just do a very simple lab, but we did not get to that. And I'm not necessarily convinced I want to do a full lab on that because it's been addressed elsewhere. And I think having them assemble a full energy storage system will be better. But I think for lab 3 of this battery class, just getting a modified inverter to a kilowatt and having them plug in to see the different components of the BMS, the lithium cells, and the inverter system at a small level that isn't very largely built out yet is going to be the way to go, at least for my students with no background or knowledge. The last thing that I found was the battery management system that we're using is is very well robust, but there's a lot of setup. I wouldn't say a lot of setup, but there's enough setup that you can rate the state of charge, the depth of discharge, and you can set some parameters for over and under voltage current conditions, which was good to explain, but it was getting to the point of too much for the students to handle. So I left them most of them at factory default, but we did get into setting the depth of discharge. We set it to what the manufacturer set and not to the BMS. So the battery manufacturer only wants you to go down to a 20% level, whereas the state of charge setting in the BMS will take it all the way down to a 0. And that got us into a conversation with how we measure and monitor the BMS. And there's some differences between our energy storage BMS products and what Rivian and automakers are doing for their state of charge and longevity of batteries. And so that was an interesting question that got posed when we were doing this, but many students still, even at this entry level, had a very difficult time understanding all of the dynamics between that, longevity of the battery storage, and how it applies to the energy storage side of the renewable energy versus what we see in the EV side. If you don't mind, if I can keep going real quick, what I'd like to do is show you the lab itself. I'll pull it over, and there we go. So hopefully on my screen, or your screen rather, you should see the actual lab itself. These videos are part of the CASE method, which is copy and steal everything. So there's some great YouTubers that actually built this very similar battery pack. And these are not the battery pack videos that I created for the lab. When I set my class up and in Canvas, I'm going to pull this up in just a second. Give me just 1 second. This in Canvas is the lab activity that the students see. So I very clearly in the beginning of the class mentioned to my students, okay, if you're in class, you do not need to watch these videos that we created here on the step-by-step guide. So being a hybrid class for this lab that we're talking about here, the students did not need to do that. I said, now, if you want more detailed information as a standalone lab, let me pull this up now, you could go and watch these videos that are on YouTube, but they will just help you explain in greater context what's going on. For everything in our class, everything lives in Canvas, and the answers to following of the step-by-step guide are in Canvas. So if you download and use my Canvas shell, you will find that the videos that I've created with the closed captioning live here in Canvas in the module with the lab of building a lithium battery pack. And then any support lab material or videos or anything supporting of it lives in the lab itself. And the reason for doing that is currently our battery class is hybrid. Rivian and a lot of our local apprentice programs really want the class to be 100% in person, which is phenomenal. So it gives me some latitude of, okay, here's where you'll find the material from my stuff, here's where you find your stuff, and here's how we do that. And then I've got the specific downloads of the prismatic cell that we have and of the overkill. We're using an overkill BMS module there for that. And it was really a pretty robust lab and activity on how we set that up. Looking at that lab one more time, all of the labs that I did follow what Scott had set up on some of his Create labs. And that was, I did a background or a question portion in the beginning that kind of highlighted what our main concepts and topics were that we wanted to cover. And then if you watched my videos or in class, we talked about these questions and the students can get their answers to. If you look at that Google Drive and you go to lab number 21, which this one is, let me bring it over. I'll show you that everything for this lab is there, including the answer key, the videos that we created, and then the supporting documentation. So even if you don't wish to do and build this in person, the students could watch that video and then answer the questions and move forward from it. So my thought is eventually, if this becomes no longer a very valuable in-person activity and we go purely energy storage, I could use this activity as a at-home activity. They can step by step go through it, answer these questions, and get an idea of what's going on. So that is kind of what you will find in all of the labs. If you look in the, you go back one more screen. If you look in your Google Shared Drive, you will find that all the labs are broken into that. Some I don't have anything, so you won't see those in the Google Drive, but I've got it all laid out for that. And then the last thing I'd like to share with you, in the Google Shared Drive is a list of all of the labs that I created here for this battery storage class, whether there was an answer key, which I now have a lot more answer keys on. I've stole a lot of stuff that I haven't got into, but Jim Pytel's series Parallel Lab was one I was looking to rip off. So thank you, Jim, for that. Ken and let me see who else. I'm forgetting who I stole from that. You were talking the IV curve. I was looking at a little bit of the IV curve here. I stole that and developed this 18650 activity. And you can see that they're all there. And then I've got, anyways, you can get the idea of what I have with all of that. So they're all fair game with that. These are just the files. So getting back to the actual lab activity, as I try to follow from Scott's layout, the students answer some questions about overcurrent, undercurrent, voltage protection. And then we get to the lab activities, and I have a list of all the items. I also have a list of all the componentry and what I ordered from Amazon and where I got the batteries. So it's in that file if you wish to order and do what we have and get similar equipment. I've got it all listed in there. So here's the step-by-step guides, and this is what we did in person. And then if they watch the videos, they could see that. So I don't want to keep beating on the same dead horse, but it was interesting. One thing that we did in person was talked about torque specs with laser welded tabs on the Rivian battery packs. They don't do a torque setting. They actually do thermal imaging. So one idea would be is to get a thermal imaging camera. And when I start running current, a little bit of current to see if any of these parts get hot, but I've not done that yet. And then we talked about lugging of crimps and how to read schematics, and on Rivian and on Tesla EV cars, they have a pretty robust wire terminal and wire numbering system. And so this would be an introduction for the students that are going into the EV repair side to recognize that how to read wires and be able to identify that. And so that was the conversation that we had with building of the battery pack there. This was already pre-built, so we just entered those wire harnesses there. And then you can see the step-by-step where we actually wired this thing up. I understand that some of it is not exactly up to code, but we're not using this to do anything more than generation of an in-class activity. We would have had a 4-post there, but I tried as best as I could for everything to have all of our supports follow NEC codes and then use all of the proper wire techniques and all of that. So that, in a nutshell, is what I've got going on. So I'm going to hit stop, and I am now done. And we can go to answering questions, and I can kind of talk about some best practices that I've learned on all of this.
Excellent, Chris. Thank you very much. You know, I guess one question I have is, can you take a step back and talk to us, because you were referring to different programs or different trainings that your students are going through. Can you sort of sort through that and where this fits into your renewable energy program or the other programs?
So I would have had a different answer 3 years ago to now. 3 years ago, when we heard Rivian coming on board, I stressed the need to our president and to our local, administrators. I said, I think we need to at least have a battery class going. And that battery class would be predominantly on the books, ready to go for whatever Rivian wants to do, but to be a support within our renewable energy. As we actually started to see some of those trends locally from the local solar manufacturers, at least mentioning it. But what Rivian really did for us was rejuvenate our industrial maintenance program, more so than anything else. And from a purely manufacturing standpoint, Rivian has single-handedly for us brought industrial maintenance to the forefront, where a lot of companies had no longer technicians. They knew they were short on technicians, but with that new company coming in town, forget that there was an electric vehicle company, but there was a new manufacturing facility that came into town. They sucked almost every available technician or incumbent technicians at other facilities into their plant. And that left a very clear void that I know most of us that is on this conversation today, or will soon be watching as a webinar on video later, can attest to. But what it did is it said we need to look at it from a manufacturing standpoint. And what the battery class here was really intended to do initially was to be a standalone battery class that kind of supported both. But what we're seeing now is it kind of morphing into a single course that might do both energy storage side of how to install energy storage and how to perform manufacturing. And what I've come to realize within the last 6 months here is I firmly believe that our programs are going to become mini boot camps. They want, what our employers are telling us is they would love to have their students come. They have no problems releasing their employees to come to school and do a 8 to 5 for 5 weeks and get through a particular block of material. And they want their employees to be trained. They realize the need for training now, but they also want it in a short amount of time, which is kind of, as we know in education, is both good and bad. There's no soak time, as it were, for the students. So this class initially, and I still think for right now in the next 2 years, is going to be great to help give the fundamentals. But what I don't know is, will this become the single class that involves solar energy storage and manufacturing? And I don't have an answer, because we only have 60 credit hours, and what they're telling us from industry we don't have enough credit classes to keep offering and expanding. So something is going to have to give. And I strongly suspect that if I do develop another class, it'll be energy storage with EV charge stations, like a combo class that's short, sweet, to the point, that just gets the fundamentals. I don't know if that's the best answer. Will it help students get into entry-level jobs? The answer is yes. Will it help them with advanced troubleshooting and advanced skill sets? I don't think so. So this class really is, and why I did this video support with the activities, is if I can unload some of these and put them online, and I can't wait to see Jim's flipped classroom approach, to get the students to do some of this online, that when we come in class, maybe we can do some more of that advanced stuff. That's where I've run into some real problems trying to build out classes. I don't know which end is up between hybrid with COVID and then traditional, meaning 18, 19-year-old kids that are graduating high school coming, and now this larger incumbent apprentice-based program. That is where I don't have an answer. I don't know what to do.
Understandable. Lots of challenges, lots of demands, right, from the industry. Are there other questions or comments for Chris?
I had a question for you, Chris. So you've been through this curriculum, I think, once now, right? You know, kind of looking back over the semester and the collection of labs, what were the parts that the students found the most challenging, or that they needed the most help? What were the sticky pieces? So if somebody tries to attempt this, what are the things that they definitely want to, you know, deliver with an instructor there to help them through the challenging parts?
With no prerequisites, my assumption was that I would start with a group of students at a clean slate, and that was 100% true. I've been teaching, I would say the stickiest point was for me to recognize that what I wanted to get through and done with the students was a little bit more than what they were at. I'll give you an example, and this is a crazy one. I'll go to a share screen again to help kind of answer that question. And that was this. I did an activity with pennies, and it was, we were going to build an introduction to simple cells and galvanic cells. And I had the students actually, make sure I got this one. Nope, this is just a watch a video. I got the wrong one. Of course, it's all being recorded, so I'm going to blow it here. But I wanted to get to this one to show you. Yes, this is it. So to give you a perspective, I did a lab where they made a lemon battery.
Oh yeah, I've done this.
and then we built at the very end of it. This was my first lab in the class. And then we did a stacking of these cells of pennies and zinc sheets with aluminum foil. And we actually did this. And I would say that this was by far and away the most impressive lab that these college students got to do. They ate this one up because we could talk about the individual cell. We talked about how the battery functioned, and it gave us a way to talk about ampacity, how much you could just, it opened the idea of what amp hours were compared to amps, what voltage was. And I was surprised that I would have thought that they would have been bored. Like, wow, I did this when I was in grade school. But this one really, truly opened my eyes to the fundamentals of what makes a battery go. And so I wanted to make sure, I don't want to turn this into a chemistry class, because you know full well, Ken, that this could become Chemistry 101 at its finest. I just wanted them to know what a galvanic equation was. I wanted them to know what the building blocks of a cell were. So when they looked at individual cells, they had an idea. Because, for example, I'm gonna stop sharing. I did. And so here is an actual Rivian cell. I don't want you to ask me any questions how this came into my possession, but this is an actual cell made by Samsung, which is no surprise, but it is a actual regular run-of-the-mill cell. And the data sheet exists out there. So the technology that they're using isn't really proprietary. There is some proprietariness to it, but not to what our technicians are doing. So having them do the penny lab, the pinch point was now they understand what the cell is made up of. Then we talked about the different types of cells, and then we got into the prismatic cells and all of that. So for example, then, I don't know how good you can see this. It's not really meant to do that. But then we kind of got into talking about what we have here and then all of the componentry that made it up. And that was a win. Rivian sounded extremely pleased with the results. Rivian is actually going to start developing an energy storage process where they take their recycled batteries and their used and worn cells from the EVs and make energy storage with it. So I know there will be a energy storage condition. That I know it's a long-winded answer, but that's what I'm seeing right now on that.
I appreciate that a lot, Chris, because I've built the lemon cells and the galvanic piles, the voltaic piles with my own students, and I agree with you. I think while it's a simple procedure, it's very helpful for getting students to understand the different components in the battery, distinguishing between an anode and a cathode and the electrolyte. And then, you know, to take the next step and actually dissect a commercial product like the one you had there from Rivian, or even, you know, cutting apart a 9-volt battery to see what's inside, or slicing through a flashlight battery. It makes it much easier for the students then to look at the different methods for assembling cells and seeing how the components are put together in a commercial product. So I can appreciate that a lot.
I was just reading that Noah asked a question about safety. And if you don't mind, I'd like to answer that with another sharing of the screen. Did I find any safety issues? The answer is absolutely not. I did not. And the reason for it is when I set this, so cell packs that Rivian makes, all EV manufacturers, and I'm going to even make a wild ass assumption that energy storage systems are going to do, are very modular. They are trying to limit the voltage of a cell pack to 50 volts or less. They are going to combine those 50 volt cell packs in series to create a 450 volt battery pack that will sit inside of the EV or inside of your energy storage system. So the goal is to try to make it as manageable for a technician or the installation side as possible. And so from a safety standpoint, everything that I do in this class, when I do a lithium ion cell, is going to use just 1 or 2 cells in series. So if you look at the series parallel activity, I have them push these in series. But I also use safety cells that have a built-in cap that limits the current. So there is a thermal overload inside of these particular cells that will limit the amount of current. So I did not run into any issues with this. The lithium iron cells were just fine because they're inherently safe. But from a safety standpoint, I was very fortunate. I did 2 activities. The very first activity, which is this one right here, battery safety and introduction, is I had them go to the University of Illinois, and I'm following the same procedures as what the U of I best practices are for their labs. And so I've got those videos here, and I talk about the safety of that. They go through that, and then they log in and they do all of the safety aspect of how we handled it, what happens if there's an overcharge, undercharge. The best safety aspect for our labs, if you're going to get into these smaller battery packs and handling them, is actually the best, absolute best thing is to get a Menards 5-gallon bucket, a couple bottles of water, couple jugs of water that stay unopened in that 5-gallon bucket, and a small box of baking soda. if you have a thermal overrun of any of these lithium-based cells, and I'm talking like, small cordless drill battery packs, and they do a thermal runaway, what we have found both at Rivian and our local fire department, they have found that it's 100% water. So if you have a thermal overrun, just dunk it in that water with the baking soda. We want the cells to actually self-discharge in the water to keep the heat going away from the cell to keep it from catching on fire. So in our lab, for this class, we just keep 3 5-gallon Menard buckets full of water, and they're ready to go. Out at Rivian, themselves, they have a rollaway, I'm going to say it's like a 55-gallon tank, but it's a little bit larger than that, that if there's a thermal overrun, they just dump that particular 50-volt battery pack into that cell for thermal runaway. So we did not run into any thermal issues. From storage, I have all of the lithium ion cells in a small pouch, and that pouch is a flame-proof pouch that we keep in a locked cabinet. So those were the things that we found with our insurance when we talked to them, what Rivian thought was best practices, and what the local fire department was finding out about.
Chris, since no one else is jumping in right away with questions, I got another one for you. The one that we always get from students, I think because they're interested in electric vehicles, is they want to learn more about how energy storage systems function at temperature extremes, and how the winter is going to affect an EV vehicle's range and stuff like that. Did any of your labs address the effects of temperature on batteries, and can you tell us a little bit about that?
Well, let me give you what exactly happened in our class to give you an answer. The short answer is yes, but not in any measurable labs. When we do our homework assignments, let me pull up Battery University. Some of you probably already know this website, but this is where we go and I have my students do reading. It's called Battery University. And they have this website. I don't know where this is. Get out of there. And this is your website that I have all about it. And they've got these individual little lessons. So the homework assignment that I assign has them do a reading, and then they answer the questions. And you can see all the questions I created. I got the answer keys on there for the readings that come out of here. And somewhere in here, there is a talk about temperatures. And during about week 4 into this class, I bring in the local fire department. So the local fire department has a small flame that they bring out, and we go out to the parking lot, and I have the students all pull an ABC fire extinguisher and they put the fire out. Well, during that time, our liaison at the fire department works with Rivian and helping set up and verify all of the battery stuff and all the safety stuff. So I can tell you a couple offline stories about batteries and a little bit of fires offline. I don't want it to be recorded. I'm sure we don't want to know. Nothing bad happened, but I'm sure that the PR would not want to go out on it. But I will say this story that the fire department told me about battery safety and cold and extreme temperatures. Exactly 1 year ago, it was very cold weather like this. So we had a train derailment, and in that train, there were some lithium cells that caught fire. Not a major fire, but enough that one of the train cars caught fire in downtown Bloomington. And so the fire department came out, and then we have a drone. So they got their drone out, and they wanted to do an aerial view of this tipped over fire car, of this car that was on fire, train car. But as soon as they got it out, as soon as it lifted up, it beep, beep, said the battery is dead, and it went back down. And that was it. Fully charged lithium cells that were in this drone had no more than 30 seconds at -5 degrees Fahrenheit. It didn't even last. So the students heard the firefighter liaison talk about that, And we used that description when we went back into our homework assignment, when we were talking about the IV curves and looking at how the performance will drop off over hot and cold. So that was what we used for that one. But I actually just talked about that in a homework assignment.
That's a great real life application story. I like that one. I'm going to try and remember that with my students.
Any other questions for Chris?
Thanks, Chris Falk. Yeah, that's where it was, the 502 activity. If you go to the batteries, yeah. So please feel free to use that material that I created. If you think it's of value, it's great. If you find anything that I need to update or it can do better, I appreciate it. And hopefully it helps you out if you want to steal it and put it in yours class for onesies or twosies. It's sort of an a la carte format. So as we merge and morph and go into higher and lower things, we can use it or use less of it depending on where classes go.
Chris, maybe you can post how people can reach you if they would like to give you feedback or to ask questions. And while he's doing that, if anybody else has a question or a comment.
Hi, Chris. My name's Mike, and I work with high school teachers and middle school teachers. And I always like to ask people who teach the next level, like, if we can start to lay some foundations for you. I look at all your content there, and it's a little, some high school kids could definitely take it. But, you know, I'm always curious, like, if there are some fundamental things that they arrive from middle school with high school, knowing when they get to you, it'd be great. Then we can sort of help to get those kids ready as they start to move to you.
I would say the most exciting activity was the penny battery activity and talking about cells. And I realized when I did this, that when I was in high school and doing the chemistry class, I never fully appreciated why I was learning about galvanic and voltaic chemistries. It didn't have a practical application to me. And once I did the battery class, all of a sudden, like, I don't need to know how the electrons in doing a chemical equation necessarily function. I'm going to jokingly let this, you know, Ken Walls and his doctoral information is where that goes. But from a purely understanding standpoint, I would have been so more intrigued in understanding, oh, that's why lithium is a very popular metal right now for using of a battery. That would have been key to helping squash some of the initial questions from students. Well, why can't we do this? Or why can we do that? And then the other thing was just the fundamentals of series and parallel, even if it was just with AA batteries, just understanding how very fundamentally things work. As even some of the adults that were in the EV program from Rivian did not fully believe in Ohm's law. Like, no, that can't be. Like, you cannot, this car is not going to give you 500 miles of range. It simply cannot do that. And they kept thinking there's this magic that's going to perform itself. It's like, and that takes time. And that took a long time for me to understand. And I'm sure most of us can relate to that. It took a long time. So if we could start that early and hit it again and again and again, even when they become adults, it finally, that soak time is going to be way more important than rushing through a class. But I don't see us getting away from these short courses going further. So that would be my answer, is just helping us with the fundamentals. It's not glamorous, and that's all we're doing really, is teaching the fundamentals.
Thanks.
Yeah, nice points, Chris. Other questions or comments for Chris? All right.
Wonderful.
Well, not seeing any hands. Yes, thank you very much, Chris. Once again, I've learned a lot by hearing you talk about batteries. So we will have this presentation posted at the createenergy.org website coming up fairly soon. And as Chris posted the chat his contact information. Definitely contact him with questions or comments or suggestions that you have coming up. Thanks to everybody for joining this webinar. Hopefully we'll see you soon.
Absolutely. Well, thank you for your help, Gabby, Ken, and Joel. Have a wonderful day.
Oh, yes.
Good
Hey, thanks a
job.
bunch, Chris. You did great. I
Yeah,
really enjoyed
awesome.
that, and I'm looking forward to digging in further to some of your materials and hopefully getting to use some of that content with my own students. So,
Well, if you run into problems, let me know. I appreciate all the help over the years from you guys. It's been